Okay, so now we're going to get into a couple more practical examples of making use out of some conditional code. So in this first section, we're going to be taking a look at securing integer boundaries. So this is going to expand on the concept that we just left off on with our logical operators, where we were checking the bounds of some set of numbers, so say like that 20 and 40, that we were checking to see if values were inside of or outside of that range. The other thing we're going to take a look at is going to be dealing with certain specific conditions with our double or our floating point data types. So for this first part, we're going to be looking at integer boundaries. So expanding on the concept of ranges, the boundaries of various data types can be checked by using the min value and max value constants of each of those particular numeric data types. So for example, with this one, we're going to be taking a look at the min value and max value of the integer class. So that integer class is going to be what's associated with our int primitive data type. So we can see two variables right here that we're creating. Both of these are going to be using that int data type. So you've got int number 1 and int number 2. So number 1 is going to have a value assigned to it. It's going to be the maximum value for our int data type. It's going to be that upper bound of about 2.1 billion. And with number 2, we're just going to assign the number 1 to it. The third variable that we have right here is going to be a double that we call larger result. This is initially going to be 0, and eventually we're going to be using this to hold the result of number 1 and number 2 because of the fact that whenever we test out this addition with these, when we add them together, this will give us a number that's outside the bounds for the int data type. And so because of that, it's going to result in that overflow. So we saw previously what happens with overflow, where if we hit one of the bounds for our data type, it's just going to wrap to the bottom. And so what we're going to end up getting, if we don't do this conversion, we would just get the min value for an int. So it's going to become about negative 2.1 billion. So obviously this isn't really what we want it to do. We prefer that it just add 1 to the number. So we go up to about 2.1 billion with an 8 on the end instead of a 7. So to kind of check for this and make sure that everything is being handled correctly, we're going to be using this conditional code right here, where we're going to say if the sum of these two numbers is less than the minimum value, or if that sum is greater than the maximum value, meaning that in either one of those cases, if it's outside the bounds of an integer, then we want to go ahead and just treat them as doubles and add them together and then assign them to this larger result double. And to kind of add on to the specific details about what we're doing here, you'll notice that for each one of those checks that I'm doing, I need to go ahead and use the cast operator. So we're going to have that cast operator double. So number 1 will be converted to a double. And then because of the rules for conversion and performing math operations, number 2 will also be treated as a double. And when I add these together, the result will also be treated as a double. And so because of this, because I'm going to treat the result as a double, I no longer have to worry about that integer overflow, because if it's treated as a double, well, 2.1 billion very easily fits inside the range for a double, which is closer to about 10 to the 308th. And then finally, in the conditionally executed code, where we might be assigning this to a larger result, we're going to do the same thing. We'll cast number 1 to a double. Number 2 will be treated as a double. We add them together. The result is temporarily treated as a double, and then that's going to be assigned to a variable that is a double. So go ahead and minimize this. We'll come over to Netbeans and go ahead and put this code together. So right here, we'll go ahead and create a new project. So we're going to go and make a new Java application. Click Next. And right here, the name that I'm going to give to this project, it's going to be related to both the concept that I'm covering now, as well as the next concept dealing with the double data type. So the name that I want to go ahead and give this is going to be Securing Numeric Values. Go ahead and click Finish. And so then, once we've got our code, we'll go ahead and clean this up a little bit, removing the extra comments that we're not going to be using. Go ahead and make some adjustments to the style as well by repositioning the curly braces. And then right here inside of the main method, we'll go ahead and start adding in the couple of variables that we have, as well as that conditional code. So we're going to put our int number 1. So this one's going to be equal to the maximum possible value for the integer, or the int data type. So we could just use this 2.1 billion that we have right here. Alternatively, as we've just seen, we have a constant that holds that value anyway. So rather than trying to memorize the roughly 2.1 billion number that we have right here, we could just more easily remember the constant that holds that value and just use that instead. So I'm going to go ahead and do that right here. So we're going to use our integer class, we have a capital I there, and we're going to go get the max value from that. And you can see right here, when we go to get this constant max value, if we have this little annotation displaying for it, it's going to show you the value that's stored in that constant, so that roughly 2.1 billion. You can also see how that value is derived. This 2 to the 31st minus 1 is how we get this value of about 2.1 billion. So we'll go ahead and choose this constant, and then close that off. And so now we're just going to go ahead and assign that value to number 1. For number 2, we're going to do int number 2. We'll go ahead and assign to this the value 1. And then finally, for our variable declarations, we're going to create a double that will hold the result. So we're going to say double. This is going to be larger result. This will be initially equal to 0. And then we can go ahead and start putting together our conditional code. So we're going to say if the sum of number 1 and number 2, but we need to make sure that we cast one of these two numbers to a double so that when we actually add them together, it doesn't give us that integer overflow and kind of mess with our results. So we're going to go ahead and do double right here. Do number 1 plus number 2. So if this result is less than the min value, get that min value right there, and then we'll go ahead and take all of this, because we're going to be using it a second time in a moment, and then we're going to say or, and from here what I'm going to go ahead and do is just wrap this to the next line, because otherwise it's going to start going kind of off the page. So I'm going to push enter and just move this to the next line, and I'm going to go ahead and put in the rest of this right here and say in this case if it's also greater than the max value. So if either one of those two conditions are true, then we want to go ahead and store this in larger result instead. So then we can go ahead and put together the actual code for this. And because of the fact that I have this wrapping to the next line like this, to make sure that it's pretty clear which lines correspond to the condition and which lines correspond to the body, I'm going to go ahead and include a pair of curly braces right here. That way we can easily distinguish between one and the other. And so right here we're going to do our larger result and say this is equal to, again we're going to use the cast operator. So we'll cast number 1 to a double, and then we're going to add number 2 onto it so we can get the final result. And then once we've done all this, we'll go ahead and do a print statement right here. We can say the result is plus and then larger result. Go ahead and save that. And so then if we go ahead and run this, it's going to do this addition based on the fact that this condition is true. So we're going to be storing this into larger result. So if we run this and we take a look at our larger result, it's going to be 2.147 times 10 to the 9th. So you can see it being converted into the scientific notation, which is only going to happen if it's being treated as a double. So then the question is, what happens if we add these two numbers together, but it's still within that range of an integer? So maybe we're in a situation where we don't need to do this cast operation to a double, add them together, and then store that into a double. Maybe instead we just want to do regular integer addition and then store it into an integer. So how do we account for that situation? So what we can go ahead and do is just add another variable right here. So we're going to have another int variable. We'll call this one just result. and say this is also initialized to 0, since we will eventually add some numbers together and then store that into a result. Just kind of replace the 0 that's in there. And then what we need to go ahead and do is include an else statement right here. So we're going to say if this condition right here is true, we want to do all of this conversion, this casting to doubles, and then store the result as a double. But if that's not true, so say else, we want to go ahead and just do regular integer addition and store it into an integer. So we're going to say that this result is going to be equal to our number 1 plus number 2. Okay, and then the other thing we need to do is we've got a result right here, but we're going to print out whatever is in larger result. So what I'll go ahead and do to be able to show which one of these we're actually getting a value for, I'll go ahead and just have both of these print out. So I'm going to say system.out.println, and right here we'll say the result is plus result, and for this one we'll just go ahead and change this slightly and say the larger result is, and whatever is in larger result. And so now if I go ahead and run this again, just leaving the values as they are so we can see this, so result is going to be 0, larger result is going to be the sum of these two numbers. So then if I go ahead and just make a very simple change to this, I'm going to change number 2 to 0 and go ahead and run this again. And now the result is going to be that 2.1 billion. So it's doing the integer addition and storing this into result. So you see that printout right here. And then the larger result, we don't do any addition with that. So this value is never going to change. It's just going to stay this 0 that we have right here. And so we're going to see that 0.0 printing to the console. So based on all of this, we can see the two different cases. One where we are trying to do addition, but we see that the number is too large to fit into the int data type, so we'll change it to a double. And then another case where we see, okay, it's going to fit inside of an int, so we don't need to do this conversion to a double. We'll just go ahead and store it in an int instead. So the other thing that we want to talk about is going to be dealing with floating point inputs. So if an arithmetic operation using doubles results in a number that goes outside the range of the double data type, the way that this is going to be interpreted is going to be as the value infinity. So with our double data type, it doesn't deal with overflow like integers do. Instead, what it's going to do is it will stop treating it as just some finite number that we would be able to see and recognize, but instead gives it this value or this property of infinity. And so the way that we can check this to see if it's being treated this way is by using the isInfinite method of the double class. So we can see an example right here. We're saying double.isInfinite and then some number that we want to go ahead and check, and we're going to do system.out.println. This number is too large. In addition to this, we can also check based on certain arithmetic operations. For example, dividing by 0. If we do this with doubles, it's going to give us a result that is not a number. So it's going to give us this nan value. So again, just like with infinity, what this means is that it's not going to treat it as some finite, easily recognizable number, but instead is going to associate some property with it. In this case, it's going to be the nan property. So we're going to need to use the isNan method of the double class to check for that. So in this case, we're saying if double.isNan, and then we're checking some number. We can go ahead and do this print statement saying this is not a number. So let's go ahead and take a look at two more examples, one for each of these conditions. So for this first one right here, dealing with isInfinite, I'm going to go ahead and just add on some additional code right here. So we'll have some slightly different variables to work with. So what I'm going to do is use a double. We'll call this very large number 1. This one's going to be equal to, let's say, 2e to the 200. Okay. And then in addition to this, I'm going to say double very large number 2. This one's also going to be equal to 2 to the 200th. And what I'm going to do is just multiply these two numbers together. So we're going to get a result We need to store that somewhere as well. So we'll call this our very large result. This one's going to be equal to these two numbers multiplied together. We're going to have our very large number 1 times our very large number 2. And so when we multiply these two numbers together, it's going to be this 2 to the 200th, or 2 times 10 to the 200th, multiplied by 2 times 10 to the 200th. So we're going to multiply these two values together, so that'll give us 4. And then to manage the powers, we're going to add those together. So this will end up giving us 4 times 10 to the 400th. And as I mentioned before, the range for a double only goes up to the 308th. So if we go up to the 400th power, that's going to be outside the range of a double, meaning that this will instead now be treated as that infinite value. So what we want to go ahead and do is just have that check right here. So we're going to say if, using the double class, so you have a capital D right here, is infinite. So we're going to go ahead and use this method to check for that. And what we're going to put in here is going to be our very large result. And then we'll go ahead and do our print statement, system.out.println. We're going to say this number is too large. So if we go ahead and run this, we'll get these two statements here. We're not going to worry too much about those. We'll focus primarily on the last statement. And we're going to see that right here. This number is too large. So that's going to tell us that very large result is holding that infinite property. And additionally, we can go ahead and take a look at the isNan property. So to do this, I'm going to use a somewhat peculiar case. This is going to be the easiest way to demonstrate a situation where we can get this double to be treated as not a number. So what I'm going to do is basically just 0 divided by 0. That's going to give me a result that will be considered not a number. So I can go ahead and check this isNan property. So we're going to go ahead and create two doubles for our dividend and our divisor. So we'll go ahead and do double num1 is equal to 0. Go ahead and do another one, double num2. That's also going to be equal to 0. And then we'll go ahead and create our result. So we'll say this is our quotient for this one. So we'll do double quotient is going to be equal to num1 divided by num2. And then what I can go ahead and do is create another if statement. This time we're going to be using the isNan method from our double class. So I'm going to say if double.isNan. And then inside of here we're going to put in our quotient. And then the statement that I will conditionally execute is going to be a print statement just saying this is not a number. So we're going to say system.out.println. And right here, we're going to say this is not a number. Go ahead and save that. And then if we go ahead and run this, we can take a look at that print statement printing to the console. So you see right here, this is not a number. So at this point, this is going to wrap up a couple of the different cases I wanted to look at for securing our numeric values. So we saw a case of checking the boundaries for our integer numbers or integer data types, and also a couple of cases for our floating point data types, particularly with doubles, taking a look at this isInfinite and this isNan method for checking certain kinds of exceptional values for our doubles. So in the next video, we're going to go ahead and start taking a look at now is going to be some of these Boolean expressions or these comparisons dealing with the string class. So we're going to be taking a look at how to compare objects of the string class.